Alright, so exponential functions look like this. F of x is equal to, let's say, b to the x, where b is just any positive number. So let's just work through an example of what some exponential function might look like. We're not going to pick 1 because that wouldn't really work very well, because 1 to the power of anything is still just going to be 1. So we'll just ignore that for now. So let's try graphing. Let's say y is equal to 2 to the x. That's a nice easy number to work with. So let's just make a little table here of values like this. And we'll put our x values here for our inputs and our outputs over here as our y values. And let's just pick, let's say, -3, -2, -1, 0, 1, 2, 3. Just so we can kind of get an idea of what this might look like. So let's start plugging in some of these values for x. If we take 2 to the power of 0, we actually get 1. That's kind of an interesting thing, like anything to the power of 0 is just going to be equal to 1. So with that said, actually, every exponential function with this form is going to pass through this point 0, 1. Just something to note down. Anyway, so let's put in the other values for x. So 2 to the power of 1 is just 2. 2 to the power of 2 is 2 times 2, which is 4. And 2 to the power of 3 is 2 times 2 times 2 is 8. 2 to the power of -1, here we'll write it down here. 2 to the power of -1 is the same thing as saying 1 over 2 to the power of 1, which is equal to 1/2. Now if we had 2 to the power of -2, that's the same thing as saying 1 over 2 to the power of 2, which is 1/4. Right? And if we keep going with this, we'd see that 2 to the power of -3 is the same thing as 1 over 2 to the 3, which is the same thing as 1 over 2 times 2 times 2, which is 1 over 8, or 1/8. Right? Having a negative exponent just puts it down in the bottom of your fraction. So we can plug these values into our little table up here. And so 2 to the power of -1, our y value was 1/2. And then the next one was 1/4, and then the next one was 1/8. So let's draw this and let's see what we get. We already know that we have the point 0, 1, and then we'll go over the next point we have was 1, 2. At this point, the next point we had was 2 and 4. 2 and 4. And the next point we would have was x is equal to 3 and y is equal to 8. So that's 4, 6. So it would be somewhere up about there. And now if we go to the other side of the y-axis, we'll see that -1 was equal, its y value was about 1/2, so just roughly in there. -2 was 1/4, and then 1/8. And it's getting closer and closer to the y-axis, but it's actually never going to touch because 2 to the power of x can never be equal to 0. It'll just be like a progressively smaller and smaller number. It will never actually touch the x-axis though. So we get this nice curve, if I can draw it. It's going to look something like this. And it's going to go up, and it's going to keep going up. Oh, not that way though. I think you get the point. It's going to go up like that. So that's just what a typical exponential function looks like, and just note that they always pass through this point 0, 1. And I guess the last thing to say about them is the domain you can see here is going to be all of the real numbers, because it's going to go all the way that way on the x-axis, cover every possible negative number, and for every, you can just keep going this way, like it's just going to keep going up. And the range is just all of the positive y values that are greater than 0. It does not include 0 because it never actually touches the x-axis.